All right, guys, welcome to the very last two sections, which we're going to combine into one. So here we are in chapter 10, talking about correlation and regression. And you may remember from way back at the start of the quarter, we said something about correlation. Particularly, we said that correlation does not imply causation. Just because two things are happening together doesn't mean one of them's causing the other one. However, I'd like to bring this around and just say that correlation can still be useful. Just because one thing's not causing the other thing doesn't mean we can't use one to predict the other one. Say, hey, if these two things go together, when I see one, I'm going to be more likely to see the other one, even if they're not causing each other. If they tend to swim together, then I can use that to make predictions. Okay, so in 10.2, the real question is going to be, is there correlation? And in 10.3, the question is going to be, if there is, what can we do with it? And they fit very naturally together. So we'll talk about that a bit. But let's talk about how to figure out, is there correlation? And really the first way to see that, which I think we've already done in this class, is just to take a look at the scatter plot. Plot the two data sets as a scatter plot, see if things line up. So let's take a look at some examples of some scattered plots. And let's see, I think I'm going to need to get out of the way here for a second. Okay, so these are a few possibilities for what might happen when you plot your data. And one thing that we're going to do is just look at the scatter plot visually and just say, hey, does it seem to be lined up? And we've got examples here from a perfect positive correlation. Positive just means as one thing gets bigger, the other thing gets bigger too. So there's a perfect positive correlation, and a strong one and a weak one, still positive, kind of a general upward trend. The one in the middle is like no correlation. The one thing does not seem to predict the other thing at all. It's just a cloud. And then we go into looking at some negative correlations, weak and strong and perfect. I want to point out that there's something here that we'll measure shortly called a correlation coefficient. And the correlation coefficient looks at how closely the data fits a straight line. So you imagine the best fitting straight line. I put a straight line as close as you can. And how well do those points fit that line? And the correlation coefficient is written as, or abbreviated as R. So this one might have an R of, I'm just guessing here, of like 0.8. You look at this one and you see what's the best fitting line here. It still looks about like that, but the points don't fit as well anymore. I guess this might have an R of more like maybe 0.4 or something. This one, of course, since it fits perfectly to a straight line, this one has an R of 1. This one, I don't know, the best line I could probably fit to this would look, I don't know, probably about like that. This is an R of, maybe it's not quite 0. It's rarely perfectly 0, but this will be an R of like 0.002 or something. It's just basically 0 relationship between the two things. And then these things, of course, would be the same idea in the other direction. There's the best fitting line. The R is probably, and since it goes the other direction, since it's a negative correlation, the correlation coefficient will actually come out negative as well. And just says as one thing gets bigger, the other one tends to get smaller. So there's a correlation coefficient of maybe negative 0.4, correlation coefficient of maybe negative 0.8, and then again this one will be a perfect correlation coefficient. Perfect correlation coefficient of negative 1. The correlation coefficient is a percentage. It can just be positive or negative. So the best, a perfect fit will be 100% positive correlation, or an R of 1, and a negative correlation of -1. The thing we have here, the question that still remains is, what correlation coefficient is good enough? 0.8 seems pretty good, but is 0.4 good enough? I mean, there is kind of a trend there. I can see a relationship, but is it good enough to make predictions? And again, we don't want to just say seems good enough. We want to have a decision procedure. And we already have a nice decision procedure in general in hypothesis testing. And it turns out that we'll be able to run a hypothesis test to say, is there correlation here or is there not? We can't really decide that based on the R value, but we can decide that based on a hypothesis test, which we'll look at shortly. So let's test a hypothesis. I've got a question. Say, is there a correlation between sodium content and calories in fast food items? Let me show you how hypothesis testing works here. And actually, let me just say we're going to check the correlation 3 ways. We're going to look at the scatter plot. Just give ourselves a visual idea. And this is what you're going to do in your homework too, by the way, is you're going to do these 3 things for every problem. You're going to look at the scatter plot. We're going to compute the correlation coefficient. Compute the correlation coefficient, also known as R. And then we're going to do a full hypothesis test. And these sort of go at an increasing level of certainty. All right, looking at the scatter plot, you're just making a visual guess. The correlation coefficient, at least that gives you a number. But the hypothesis test is really the ultimate answer. It'll tell us yes or no. And the hypothesis test, I'm just going to tell you what the hypotheses are right now for every single one of these. The null hypothesis is always, like all null hypotheses, is going to have an equal sign. The null hypothesis is that the correlation amount is 0. If you want to translate that into plain English, instead of 0, you could say no. So the null hypothesis every single time is going to be there is no correlation. And the alternative hypothesis is going to be that the amount of correlation is not 0. Or that there is correlation. And that's the test we're going to run every single time. So those will always be our hypotheses. So let's go ahead and see if we can do all 3 of these things for my question. Is there a correlation between sodium and calories? We need some data. Fortunately, I went and found some data. So in StatDisk, I've got 16 fast food items with their sodium content and their calories. And we will head right to analysis. And we are now right here on this line, which is correlation and regression. So go ahead and punch into correlation and regression. It does say, since we're going to run a test, it's going to say what's the significance level. I didn't say otherwise, so assume the default to 5%. And then it just says select the columns. I kind of want to see the data again. So select the columns. Sodium and calories are the only columns, but I'll select those. And let's go ahead and evaluate. Okay. Maybe I'll go ahead and hide that now. There's several things going on here, and we'll take a minute to unpack all of this. But first of all, punch over to the scatter plot. There is a scatter plot there. They put that line of best fit in there. I do want the scatter plot on your homework. So if you are doing your homework with some sort of cut and paste ability, or you can print them off or just cut them into a separate document, I do want to see the scatter plots. So you can do a screenshot of this. If you punch this little camera icon, it will let you download this as an image file. If you are not doing that, if you're just doing your homework on a piece of paper, which is the case for most of you, I do want you to take a minute and actually copy this scatter plot down. It shouldn't take you like 5 minutes to do it, but take like 1 minute. So take some time to draw XY axes and actually put the points more or less in the right spots. So let's see, this screen is going to go away as soon as I go over here. But yeah, take enough time. I don't need you to label axes. So I'll just say this scatter plot should look like this, because all we really care about is the shape of the data. And so don't label axes, but do put the points in the right spots and say, okay, I've got 1, 2, 3, 4, 5 down there. I'll try to 1, 2, 3, 4, 5. Hopefully you can look at your paper and the stat disk at the same time. So get 5 in there, and there's kind of 1 up over here. 1, 2, 3, and a little cluster over here. There, and there are a few up there. So do take a little time. Like I said, that took me probably 60 seconds or less. But give me a little bit of accuracy for the scatter plot. So going back to stat disk, I'm looking at the scatter plot. I'm thinking, if it's correlation, it's not perfect, right? But is it good enough that we can actually make some predictions? I don't know. So let's go back to the results. Let's look at the correlation coefficient R, which is listed right here. It's actually 79% correlation, which is better than I would have thought. So 0.786, I'll write that down for my R. R equals 0.786. So 79% correlation seems decent, but is it good enough? So let's go ahead and look at that hypothesis test. The null says there's no correlation. The alternative says there is correlation. So if we can reject the null, that means we know for sure that there is correlation if we reject the no correlation idea. So let's see if we reject the null here. Let's go back to stat disk. The p-value, yay, is nice and small, 0.00030. Which means we reject the null. And I don't need you to write a full sentence here. I just need you to say reject null. So there is correlation. That's really all that 10.2 asks you to do. I'm going to have you continue on. So 10.3 has the exact same questions, and it just asks you to make a prediction. So it says, okay, so there's correlation. Let's make a prediction. Let's say if a fast food item had 500 milligrams of sodium, how many calories would you expect? So yeah, let's actually make that the question. Okay. So we need some way to make those predictions. We've said, hey, there is a correlation, there is a relationship. So let's see if we can use that correlation. So go back to stat disk. And look down here at the regression results. This will take a little bit of translation, but for those of you that like your algebra, this should make you happy. We've got an equation of a line here, a y equals mx plus b, although they label the things a little bit differently. M they call b1, so there's b1x plus b0. But they just say, hey, this is the equation of the line, here's the slope. So just fill in b1 with 0.193 and b2 with 115.6. So I'm just going to copy this down. I'm going to copy down y equals b0, which is 115.6. I'm going to round a little bit. Plus 0.19, yeah, I'm going to round a bit there too. 0.19 times x. And this is an equation that says if you fill in my x value, whatever was on the x-axis here, I told you didn't need to label them, and now I probably want to label. So this was sodium. Then it will predict whatever was on the y-axis, calories in this case. So I just asked you to plug in 500 milligrams. So that's just calculator work. I need to plug in 500 where the x is. So I'm going to get my calculator app. And I'm going to say I want 115.6 plus 0.19 times 500. You can see I got my little thing typed in properly. So it predicts for 500 milligrams of sodium, it predicts that that'll be about 210.6 calories. Okay, so this is the idea for 10.2 and for 10.3. 10.2 was saying, is there a correlation? So that was these three steps right here. 10.3 was saying, if you've got correlation. What's wrong with my 3? 10.3, if you've got correlation, make a prediction. I know this video is getting long, but the last thing we need to say is, what if you don't have correlation? So let's talk about that. Hey there. So what if you don't have correlation? If you don't have correlation, you shouldn't be using that equation of that line. If we don't have correlation, we've decided that we're looking at something like this right here, and that line is not going to be a good predictor. So don't use the line. So what if you don't have correlation? Stat disk will still spit out an equation, but don't use it. Instead, just give the average. The average of what you're trying to predict. Okay, so let me go back to stat disk and say, suppose that this came out that there was no correlation. Suppose this p-value came out 0.62 or something and we couldn't reject the null. Suppose there was no correlation, but I was still asking this question. If there's 500 milligrams of sodium, predict the calories. And you're like, I don't have correlation. I don't know how to make a prediction. The best prediction you can make is just to give me the average calories so far. So if we're trying to predict calories, I'm going to say there's no correlation here. I'm just going to give you the average amount of calories. So the average of this list right here. And you remember how to find the average of a list, right? In StatDisk. It's back under data. And let's explore the data, the descriptive statistics. So you would say, I want to explore the calories. And amongst all the other things here is the mean. It just says, hey, the average calories in this list was 267.6. 267.6. That's the average of the y's. And so in the back of the book, they'll list that as y bar, just to indicate that's an average, right? Remember x bar, which is our sample mean. This is our sample mean, but it's the y values. So if your answer doesn't seem to match in the back of the book, look and see if they're saying this. If they're saying that, that means there's no correlation and you used the line when you shouldn't be using the line. Okay, I'm going to walk through exactly what I want you to do in the homework in the next video. So I'll see you there.